Number 4. Multiplication identity. Let A be any kind of set where A belongs to A. There exists a number E belongs to A such that A times E equals to E times A equals to A, which also belongs to set A. Then set A satisfies the multiplication identity law. We are talking about the multiplicative identity. Again, we just let A any kind of set. It can be any kind of set where the element A belongs to A. Element A belongs to A. There exists a number which is E. It also belongs to A such that A times E equals to E times A equals to A. If we take its product with the A, you will get back the same A. On either side, if we take its product with the A, you will get back the same A. A belongs to set A. So if such is the situation, then set A satisfies the multiplicative identity law. Now what will be E? What kind of number we're gonna have for the E? That if we take its product with the A, you will get back the same A. Obviously E is 1. E is 1 here. For the multiplicative identity of A is E. It is E. It will be 1. If you take its product with 1, you will get back the same A. A times 1 equals to 1 times A equals to A. A belongs to A. So we have to check the 3 areas. First, to check the elements of A, that they belong to set A. Second one, that the number which exists, like 1 here, it belongs to A. Finally, if the final answer of this expression equals to the number which also belongs to A. If you confirm these 3 areas where A belongs to set A, E belongs to set A, and final answer belongs to set A, then we can say that A satisfies the multiplicative identity law. Multiplication identity is applicable for all the below sets except Q prime, which is a set of irrational numbers. So it can be a set of natural numbers, can be a set of whole numbers, can be a set of real numbers, can be a set of integers, can be a set of rational numbers, but cannot be a set of irrational numbers. We have used multiplication binary operation here. Look, we have no issue with the A. A can be any elements from any set, but we have problem here with the E. E is 1. E must belong to set A. Must belong to set A, which means that A should be a set where A belongs to A, E belongs to A, and this A belongs to A. What is E? E is 1 here. You have to take the product of 1, only then you will get back the same A. E is 1. So what are those sets where 1 exists? There is no doubt, instead of natural numbers, 1 exists, instead of whole numbers, 1 exists, and instead of real numbers, 1 also exists. 1 can be real numbers, can be rational numbers, can be real numbers, because remember, real numbers is the union of rational and irrational numbers. They can be rational and can be irrational. What is 1? 1 is a rational number. In fact, 1 is not an irrational number, but if the element only belongs to rational or irrational, it still comes under real numbers category. It can be a set of integers because we have positive 1 here in the set of integers. 1 exists in rational numbers here as well, but 1 does not exist in irrational numbers. In pure irrational number set, 1 does not exist. All the elements have root values, so 1 is not a part of irrational numbers. Again, you might be confused that look, real number is the union of rational and irrational numbers, which means it is applicable for the real numbers. So if it is applicable for the real numbers, it means that it is applicable for the irrational. No, it is not the case. As I told you, real numbers is the union of rational and irrational. The elements can be rational only, can be irrational only, can be the union of rational and irrational. They come under real numbers category. But if you take purely irrational number set, if you take purely the set of irrational numbers, then 1 does not exist there. So except the irrational number, multiplicative identity is applicable for all the rest of the sets. But what kind of binary operation we have used? Multiplication. This multiplication is the binary operation here.